Charles' law is an essential Chem 1 concept to understand. So if you're trying to learn this, you should pay attention to this video. I'm going to be covering everything regarding Charles' law, and I'm going to do a practice problem at the end. Basically, Charles' law, all it is, Charles' law is a law that states the temperature in Kelvin, and that is very important to know that is in Kelvin. It can't be in degrees Celsius or anything. It has to be in Kelvin all the time, is directly proportional to volume. And another important thing to know, a lot of chem professors put this on their tests, is they want to know if you understand that it's directly proportional to volume. Boyle's law is inversely proportional, and Charles' law is directly proportional. That's definitely something to know. So pretty much, other than those two things, that it's in Kelvin and it's directly proportional, you're going to need to memorize this equation here. That's essential to know. The problems are really easy to solve once you have those three concepts down. When you understand that it's in Kelvin and it's directly proportional, and you understand that equation, that's all you need to know to solve it. The rest of it is just plugging stuff in. And yeah, the equation's volume, the initial volume over the initial temperature, is equivalent to the final volume over the final temperature. I can explain that down here. We have a practice problem that says at 290 Kelvin, the volume of a gas was 24 liters. If the temperature decreases to 254 Kelvin, what is the resulting volume? So, to do this problem, pretty much all we need to do is we have to find out our volume 1 and our temperature 1. So those are our initial volumes and temperatures, and also our finishing volumes and temperatures. Now remember, we're looking for volume 2. We don't know that, but we do know our final temperature, which is 254 Kelvin. Our initial volume is 24 liters, and our initial temperature is 290 Kelvin. Now, all we have to do to solve this problem is just plug that in to our original equation, and we're going to get 24 liters divided by 290 Kelvin is equal to, and remember we don't know V2, that's what we're looking for here, divided by 254 Kelvin. I'm going to scroll down a little bit. So from there, we're going to cross multiply. This is how I do it, at least. I cross multiply, and what I get is 24 liters multiplied by 254 Kelvin, and that's equal to volume 2 times 290 Kelvin. Now what I'm going to do is I'm going to divide 290 Kelvin to isolate that our final volume here. I want to get that on its own. So divided by 290 Kelvin on both sides, and then we're just going to solve from there. So 24 times 254 and divided by 290. So our final volume is 21.02 liters is our final volume. Now remember, with chemistry problems, we're always going to want to account for significant figures. Let's go up to our problem. So our smallest number here is 24, so we're going to be going to two significant figures. So our answer is 21 liters is our volume 2. One thing you guys should know, and this pops up if you're in a Chem 1 course or allied chemistry, 99% of the time, your teacher is going to put on a test. He's going to say, he or she is going to say, they're going to incorporate degrees Celsius into the problem somewhere. So instead of saying 273 Kelvin, they might say 0 degrees Celsius, and they're going to expect you to convert that to Kelvin. So all it is you just go 0 plus 273 equals 273 Kelvin. Kelvin is degrees Celsius plus 273, that's all it is. So if it's 10 degrees Celsius they give you in the problem, before you plug that into your actual problem, you're just going to want to add that by 273, and that gives you Kelvin. Alright guys, so that's Charles' law. Like I said, I'm going to be covering, I've said it before, but I'm going to be covering all of chemistry, calculus, trigonometry. I'm going to be covering a bunch of curriculums over time here. So if you subscribe to me and you ever have any questions regarding any high school or college basic curriculums, most likely it's going to end up on my channel. Alright guys.